Example type 4 is a polynomial times a polynomial. And again, yesterday when we did this, and it was a binomial times a binomial, we talked about how it was just double distribution. So if I turn back to yesterday, when it was a binomial times a binomial, you took this first term in the first binomial and multiplied it to both terms in the second binomial. So you distributed the first term, and then you distributed the second term. It's double distribution. A polynomial times a polynomial, if it's a binomial, a two-parter, it's still double distribution because there are two things that you have to multiply across. If it's a trinomial in the first spot, it's not double distribution, it's triple distribution because there are three terms in that first polynomial. So it's still the distributive property. It just looks a little different because sometimes you have two terms that you're distributing, sometimes you have three terms, maybe you have five terms, I don't know, right? It's a polynomial. You're just taking every term from this first polynomial and distributing it to every single term in the second polynomial. It's still the distributive property. It just looks a little convoluted. So we're going to do two examples. I'm going to show you one way, and then I'm going to show you another way. I'm going to show you a little more organized way. So it's still distribution. It's just hairy distribution instead of pretty distribution. All right, so example number 1. We're going to distribute. It's just going to be a little wonky. So if I give you the polynomial 2x minus 5, so it's a binomial times a trinomial. A binomial times a trinomial. All I'm doing is I'm going to take this 2x and I'm going to distribute this 2x to all three terms. And then I'm going to go back and I'm going to take this minus 5 and distribute it to all three terms. I'm distributing both terms in the binomial to the trinomial. And you can kind of do this in any fashion that you want. If you want to take 2x times x squared, what is 2x times x squared? 2x to the third, right? And then I'm going to take that 2x and I'm going to distribute it to the 8x, positive 8x. So 2x times 8x is 16x squared. And then I'm going to take that 2x and I'm going to distribute it to the negative 6. And 2x times negative 6 is negative 12x. But I'm not done yet because I've only distributed that first term. I have to go back because it is a binomial. I have to go back and distribute that second term. So I'm going to take that negative 5 and it gets distributed to the x squared. What is negative 5 times x squared? negative 5x squared. Then I go back, and that negative 5 gets distributed to 8x, and negative 5 times 8x is, bless you, negative 40x. And then I take the negative 5 and I distribute it to the negative 6, and I get plus positive 30. But my answer is not a 1, 2, 3, 4, 5, 6, 6-term polynomial. Because after you distribute, you have to go back in and simplify, combine like terms. So I'm going to put it in standard form. Is there anything that goes with this x to the third? Mm-mm. So 2x to the third. And then what I have x squareds. 16x squared minus 5x squared is
11x squared.
Positive, so plus 11x squared. And then negative 12 and negative 40 make negative 52x plus 30. And that's my answer. So it's just double distribution because it's a binomial, right? I take both terms of that binomial and I distribute both of them to every term in this problem of the trinomial. Then I combine like terms and I get an answer. Now it can get a little messy looking, especially if it's a trinomial times a trinomial, or a trinomial times a 4-term polynomial. Or the bigger it gets, the messier it looks. So what we use sometimes to make our lives a little prettier is we put it in a grid. We organize it in a grid. So let's do this example. All right, let me make something up. Let's do 4x squared plus 3x minus 1. So a trinomial times a trinomial. So let's do x squared minus 3x plus 7. So since this is a trinomial, 3 terms, times a trinomial, 3 terms, I'm going to make a 3 by 3 box. 3 by 3. So I'm going to make a grid that is 3 by 3. And again, I'm making it 3 by 3 because it's a trinomial times a trinomial. If it was a binomial times a trinomial, I would make it a 2 by 3. Since it's a 3 by 3, I'm going to make a 3 by 3 grid. If it was a 4 by 4, I'd make a 4 by 4 grid. If it was a trinomial times 4 terms, I'd make a 3 by 4. See the pattern? Sure. All right, so then I take each term and I line it up with a box. 4x squared, 3x, and negative 1. Don't forget that that minus belongs to that 1. I take each term and I line it up with a space. Then I'm going to take this guy and put it here. X squared minus 3x and positive 7. In science class, I think it's 7th grade science, when you talk about genetics and you do the Punnett Squares, where you try to predict like what color of eyes you'll have, right? This is that concept of where you take the two and you combine them into the box. So in this spot right here, I'm going to do 4x squared times x squared. What is 4x squared times x squared? 4, right? X to the 4th. Then let's go down. It doesn't matter. You could go across. Now I'm going to do 3x times x squared. What's 3x times x squared? 3x cubed. Then I'm going to take negative 1 times x squared. Negative 1 times x squared is negative 1x squared or negative x squared. Then I move to the next row. 4x squared times negative 3x. 4x squared times negative 3x is what? Negative 12x cubed. 3x times negative 3x is negative 9x squared. Negative 1 times negative 3x is positive 3x. 4x squared times 7 is 28x squared. 3x times 7 is 21x. And negative 1 times 7 is negative 7. Now the nice part about organizing it in this grid is when we get to, right, instead of having it all as a list, correct? When we get to this part, we still have to combine like terms, but here's the cool thing about combining like terms when you use the grid. It's already organized for you. When you use the grid, it's grouped diagonally by like terms. So I have 4x to the 4th. And then I have 3x to the 3rd and negative 12x to the 3rd. They're diagonal, they're like terms, which is negative 9x to the 3rd. Then I have negative 1, negative 9 makes negative 10, and 28 makes positive 18x squared. Then I have 3x and 21x making positive 24x minus 7. And there's my answer. You would have gotten the same thing had you taken this and distributed, right? And then you did this and distributed. And then you did this and distributed. You would have gotten the same thing. It would have just been in a very long line. And then you would have had to look through and see what were like terms and combine those. You'd get the same answer. The grid just makes it a little easier to visualize. It groups your stuff together. So some people really like to use the grid for one like that, for a binomial times a trinomial, where it doesn't look that messy when you list it all out. It's still okay, but the grid just allows a little bit extra organization. You could do the grid for a binomial times a binomial. Instead of foiling and making a list first, outside, inside, last, you could draw a grid. And your diagonals would combine most of the time. Now, I'm saying this just like yesterday. You may sometimes look at your diagonals and they may be different and they might not combine. So don't just assume that your diagonals are going to combine. It's still that rule of about 90% of the time they do, but sometimes they won't. All right, let's do a little bit of practice.
I used 9/4 of the page.
Oh.
I'm about to use practice on this side. How many problems we doing?
Oh, we're doing.
Like 4?
I don't know.
4.
I'm making it up. Now remember, I mean, this does take a little bit more room than what we did yesterday. It depends on how you want to set it up. All right, you're going to have 3 practice problems. Here are the first 2. You can decide whether you want to distribute by making a long chain, or if you would like to draw a grid. Both will get you the same answer. The first problem, negative 4x plus 8 times the trinomial 2x squared plus 10x minus 9. Again, you can distribute, you can double distribute. This is a double distribution problem because it's a binomial. So since there are 2 terms, you're going to distribute twice. Or if you wanted to draw a grid, since it's a binomial times a trinomial, you would draw a 2 by 3 grid. Number 2, when you get to that one, is a trinomial times a trinomial. So you'd have to triple distribute because it's a trinomial. Or if you're going to draw a grid, since it's a trinomial times a trinomial, you would get a 3 by 3 grid. As you're doing number 1, watch and check to see, do you get the same answer? Let's distribute this one. Why not? So, negative 8x to the third, negative 40x squared, positive 36x, plus 16x squared, plus 80x, that's an x, minus 72. Negative 8x to the third. 24, is that right? Negative, am I looking at this right? Negative 24x squared. Plus 116x minus 72. Did I do that one right?
Yeah.
Go mental math.
I did too much math. Probably this one.
So it's double distribution, but instead of foiling, right, because it's not as concise as a binomial times a binomial, it's a binomial times a trinomial, so it just extends. The second one, let's do a grid, just because it's going to get a little ugly. So 3x squared minus, I'm going to put a 1 in with my coefficient just to help me out, and 11. Then I'm going to put negative 4x squared, 2x minus 6. Since I have a trinomial times a trinomial, it's a 3 by 3 grid. And 3x squared, negative 4x squared. 3x squared times negative 4x squared makes negative 12x to the 4th. Let's go across this time just to be a little different. 3x squared times 2x makes 6x to the 3rd. And 3x squared times negative 6 makes negative 18x squared. Negative 1x times negative 4x squared makes positive 4x to the 3rd. Negative 1x times 2x makes negative 2x squared. And negative 1x times negative 6 makes positive 6x. 11 times negative 4x squared makes negative 44x squared. 11 times 2x makes 22x. And 11 times negative 6 makes negative 66. I look, there's no other 4x squared anywhere, so this is by itself. I look diagonally. These are like terms. 4x to the 3rd and 6x to the 3rd make 10x to the 3rd. 44x squared, negative 2x squared, negative 18x squared. Those are all like terms. 44 minus 2 is 42. 42 minus 18 is 24. Positive 24? Yes. Yes.
Wouldn't negative 4x squared times 11 be 44x squared?
Oh, you're right. My negative got caught up in my pink circle. Negative 44, negative 2 make negative 46, plus negative 18 makes, what was I at, 46, 64, negative 64x squared. Good job, Grant.
Way to go, Grant.
22x and positive 6x make positive 28x minus 66. All right, what do you think about this one? X minus 1 cubed. What do you think I'm going to tell you?
Write it out.
When in doubt, write it out. When in doubt, write it out. This actually means x minus 1, x minus 1, x minus 1, correct? We cannot make a 3D grid. Sorry.
Dang it, not again.
You cannot have a 3 by 3 or a 2 by 2 by 2. Right? It's not a cube.
Could we make it a cube though?
No.
That's the real question.
What we do is we split it in half. We're going to do this part first. So we can FOIL. It's a binomial, correct? You can FOIL it, or you could draw a 2x2 grid
I was right.
and get an answer. You're going to split it. You're going to create two problems out of one problem. We're going to do this part first. We're going to simplify x minus 1 times x minus 1 first. X minus 1 times x minus 1, just to show you that you could make a grid for this. X times x is x squared, which is foiling, right? X times negative 1 is negative 1x. X times negative 1 is negative 1x. And negative 1 times negative 1 is positive 1. And if you look, your diagonals combine. So x minus 1 times x minus 1, you could make a grid, or you could FOIL, first, outside, inside, last. Both are the same, right? Both get you the same result. X minus 1 times x minus 1 is what? What's the solution to x minus 1 times x minus 1?
Yes.
X minus 1 times x minus 1 is x squared minus 2x plus 1. X minus 1 times x minus 1, this is our homework from last night, foiling, is x squared minus 2x plus 1. I did these two problems right here and got this answer. Now what am I going to do? I have 3.
Multiply that
By the third one. I did the first two. I did x minus 1 times x minus 1, but my original problem had 3 binomials. My original problem had 3 binomials. I did the first 2 binomials. I did x minus 1 times x minus 1 and got an answer. But I had 3 of them. I only did 2 of them. So now I have to take that answer and multiply it by the third binomial, x minus 1. So now you have 2 choices. What could you do? How could you solve this problem now? We just learned how to do it. You have 2 choices. Aaron, what could you do? You could write it out. You could draw your grid and multiply, or what else could you do? You could draw a grid, or what else could you do? Distribute. It's your choice. However you want to figure this out. So right now you should be choosing which one you want to do. Do you want to draw a grid? Or do you want to distribute? If you distribute, it's not just one distribution. It's either a triple distribution. No, okay, there's still a lot of time. Or you can distribute backwards, I guess. I'm going to make a grid. How many spaces does my grid need? What kind of grid should I make? A 3 by 2. Okay, so x squared minus 2x and 1 and x minus 1. X squared times x is x to the third. 2x times x is, or negative 2x times x is perfect. 1 times x is 1x, or just x. X squared times negative 1 is Negative 1x squared. Negative 2x times negative 1.
2x squared.
Positive 2x. No x squared. And 1 times negative 1 is?
Negative 1.
Negative 1. I'm going to look diagonally. X to the third is all by itself. Then what? Negative 3x squared. Then what?
3x.
Positive 3x. And lastly?
Negative 1.
Negative 1.